It's also an ancient Greek term. When translated to English, it means love of wisdom. What does it mean? It doesn't mean it, guys. You do philosophy on a regular basis without even noticing it. Whenever you become curious about something that you look at, that's known as an observation that leads to a question. And whenever you come up with a question, your mind is going to provide you with an answer. So philosophy is a two-step process of gathering information. Step number one is your observation, and step number two is the theory that you come up with. You can philosophize about just about anything imaginable, and that's what we're going to do right now. I'm not a psychic, but I can make 100% accurate long-term predictions. I will predict that each and every single person in this room right now is going to be 100% dead within the next 100 years. How do I know that? Because human lifespans are less than 100 years, so sooner or later, we will all be dead. So the question is this: what happens after we die? Is there life after death? Some will say yes to that question. Some will say no. Some will say maybe. Some will say who knows. Most will say who cares at this point. Realistically speaking, the answer is either going to be yes or it's going to be no. Can we know for sure if the answer is going to be yes or no? Not without conducting an experiment, guys. Sooner or later, we will all find out. But until then, is there any way we can know for sure that there's life after death, or there isn't? You can conduct an experiment. How? Like the way the psychologists do. Get yourself a volunteer, get a gun, put the gun next to the volunteer's head, pull the trigger, make sure that the person is dead before you leave, and then come back about a week later and try to revive the person back up. If the person is dead for a week, are you going to be able to revive the person back up? The answer to that question is straightforward, right? No. If a person is dead for a week, you're not going to be able to revive the person back up. You cannot revive the person back up and say, hey, so is there life after death? Have you seen my grandpa? Have you seen hell? So that sort of stuff is not going to work. So if you cannot perform an experiment and find out exactly whether or not the theory is right or wrong, what do? Under the circumstances, what you do is you start applying your belief system or logic to it. You apply logic to it. If it doesn't work out, you apply your belief system to it. And whatever it is that you're comfortable with, you're going to end up settling on. And whatever it is that you're comfortable with may change within your own lifetime as well. All right, so there's no way you can actually prove or disprove something like this without experiencing it. And by the time you experience it, obviously it's going to be too late. All right, so let's take the same concept, and this time let's apply it to nature itself. I'm going to go back to what Newton came up with when he was 19, the famous experiment, the thought experiment that he came up with. Late in his life, he claimed that he came up with the theory of gravity while he was asleep under an apple tree. Apple falls, hits him in the head. He opens his eyes. He sees an apple hanging from a tree. And next to the apple, he sees the moon. He knows why the apple fell. Apple fell because of gravity, right? So his question is, if objects fall because of gravity, why doesn't the moon also fall from the sky? All right, so I'm going to ask you guys the same question. If an apple falls because of gravity, why doesn't the moon also fall from the sky? What are you guys thinking? Whatever it is that you're thinking right now, you may think that, hey, gravity does not extend all the way out to space. Well, there's a prediction here that we can test, all right? You may think, wait a minute, the gravity extends all the way out to the moon, but then again, the moon has its own gravity, and that's probably the reason why the moon is not falling. Once again, there's a prediction here that we can test. Right or wrong, whatever the prediction that you have is a prediction that we can actually test. Is there life after death, for example? There are predictions, but there are predictions that we cannot test. So if you have predictions that you cannot test, then you are dealing with philosophy. Does gravity extend all the way out to the moon? The answer is either yes or no. Whatever your prediction is, it's a prediction that we can test. If there are predictions that we can test, if there are testable predictions, what do? We test those predictions. How do we test those predictions? We test those predictions through experiments or further observations. As soon as we have predictions that we can test, what happens? Philosophy turns into science. So physics becomes the science of nature. I'm going to give you two observations. And
yeah, according to plan.
Let's stop at this point. All right, so I'm going to give you two observations. So what I want you guys to do is I want you to download the observations right now. And then write down your own theory. All right, so you will have two theories. And then you will get to submit these observations as assignments. You're not going to get tested on it. All right. You will get these back at the end of the semester. So you can actually assess your own progress.
But as the team was about to reach the end of their first arc, the cable snapped. And 4 men and 1 woman plummeted 70 feet at 8 miles per hour, slamming into the water with terrifying force.
I'm coming the outside helmet camp. Kenny.
All right, let me stop this. I forgot to do something. All right.
Myself, boys, Sarge. She does a front flip. Here we come, going into full velocity right here. Probably reached about 78 miles an hour, right about here, 78 miles an hour. You'll see the harness disconnect from the cable right there. Didn't see, just disconnect. My arm goes out, and here we come to the water. Pow! Oh, big ton of press. So look at the splash, like 40 feet. Big action, though.
All right, guys, if you don't have audio, that's fine. I can see the group chat. If you want to just type something there, that's perfectly fine. If you have a camera, just turn on the cam. If you don't, that's also fine. All right, so let's get back to this observation.
And according to plan, as they leapt off the bridge while tethered to the cable.
All right, Here's what I want to do. Show media controls.
Yeah, according to plan.
All right, so these guys are doing a pendulum move. Bunch of daredevils doing a pendulum move from the top of a bridge. And the bridge is 270 feet above the water level. So what happens while they're doing their pendulum move? Obviously, the cable snaps, and these people fall probably about 270 feet from the top of the bridge. So that's the distance that these people fall. So the question is, you got 4 people going through the pendulum move, and then the cable snaps, and they fall. They hit the water at roughly about 91 miles per hour. All 5 survive. So my question to you is, what would have happened if these people were to jump directly
Again, according
into water?
to plan, as they lift off the bridge while tethered to the cable.
Stand up. On 3 double. Great. 1, 2, 3, go.
But as the team was about to reach the end of their first arc,
All right, so
the cable
you guys
snapped,
are going roughly about 78 miles per hour right
and 4 men and
boom, they're going to hit the water at 91 miles per hour.
1 woman plummeted 70 feet at 80 miles per hour, slamming into the water with terrifying
It's about 90 miles per hour.
force.
All 5 survive.
Okay, I'm on the outside.
So instead of doing the pendulum move that you were looking
Cam.
at, my question is, what do you think would have happened if these people were to jump directly into water down below? Now, those of you guys who don't know, that's 270 feet is the same as jumping from the 27th floor of a high-rise into the water down below. Do you think that's the web and survivable?
Kenny, myself, Lori saw it. She does the front flip. Here we come, going into full velocity right here. Probably reached about 78 miles an hour, right about here, 78 miles an hour. You'll see the harness.
All right. So do you think that would have been survivable? All right. So you will find the same observation. Okay, so observation number 1. All right, so I'm just going to publish this. All right, so I'm going to save and publish this one. Okay, guys, open this up. Go into the discussion session. Open this up. And then put down your reply. Right or wrong, don't judge yourselves. It's not a big deal. So this is for discussion purposes. So come up with your theory to justify whether or not it's actually survivable. If the ordeal is survivable, if all were to jump directly into the water down below. All right, so I'm going to give you guys a few minutes to actually compose your answers. Don't worry about the spelling. Don't worry about the grammar. All right, so the only thing I need is just come up with a reply and just put down your reply right there. All right, so I'll let you continue with that one, but before I let you continue, I'm going to give you guys a second observation. Second observation is related to this video clip. Notice that the airplane is getting struck by lightning. Each and every commercial airliner gets struck by lightning twice per year on the average.
One of the very early strikes that we had, where it struck the
Yeah, if you're on the inside, you're perfectly safe.
nose boom, as many of our lightning strikes did. And it then swept up over the top of the windshield, down that metal bar that was over the top of our heads in the canopy. And I could just happen to look up, and I could see helical chunks of plasma.
So why would you remain safe, given the fact that the airplane is being struck by lightning from outside? What keeps you safe
As the
on the inside?
lightning channel broke apart as it flew back over the top of my head.
All right, so that's going to become your second observation that you have to answer. So this is your new discussion topic. All right, so you got 2 discussions. Once again, just click on reply and then write down whatever it is that you're thinking. All right, so observation number 1, and you got observation number 2. None of the questions that I give you are the sort of questions that you can answer at first glance. You always will think that you know the answer. Okay, this is one of those questions. Did you get any of them right? Of course not. You cannot answer these questions unless you're a physicist. Even if you're a physicist, you're going to have a hard time answering them. It requires really good understanding of physics. The only thing which is going for you right now is your common sense. And your common sense is no substitute for education. Here's a case that we're looking at. These guys are doing a pendulum move. Boom, 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 boom. And then what happens is the harness snaps. And then you have a pendulum move turning into a projectile motion. And then you got the splash now. Total distance from the bridge, top of the bridge, is going to be 270 feet. And these guys are going sideways right at that point. And they are going roughly about 78 miles per hour. And then notice that the harness breaks, and there's a splash down again. And this is roughly 90 miles per hour. All 5 survive hitting water at 90 miles per hour. So my question to you was, what would happen if these people were to directly jump into water from the side? Do you think they would still survive? Yes or no? All right, notice that in this case, they're falling unimpeded. So the question is, how fast would they be moving? Would they be moving faster or slower than 90 miles per hour? So what is the speed? Would that be larger or smaller than 90 miles per hour? Given the fact that these guys are falling unimpeded, most of you guys will say, of course, they're going to be moving faster. Right? If they're moving faster, do you think they can actually survive something like that? And most of you guys will say no. So my question is straightforward. If you were to jump directly into water from that distance, which is 270 feet, direct jump, 270 feet into water, a distance of 270 feet, can you survive something like that? Would you be moving faster, slower, or the same as 90 miles per hour? So that's what the question was. The second observation is related to this. The airplane is being struck by lightning. You're on the inside and you're feeling perfectly safe. Why is it that you're perfectly safe inside an airplane? It's just getting struck by lightning. What's your theory on that? Potentially, you can come up with 3 theories. Number 1, the outside is metal, which means that the outside is going to be a conductor. So the current is going to reside on and in the metal. That's what it means. And then you're not in direct contact with the metal of the airplane because you have insulating material between you and the airplane. And then the third response that you can come up with is either the airplane is grounded or it's not grounded, whatever that means to you. Those are the common responses that I usually get. So your common sense is straightforward. It says A, you're not in direct contact with the metal of the airplane. That's the reason why you're safe. So here's what I'm going to do. I'm going to get rid of that insulating material between you and the metal of the airplane. What if you're touching the inside of the metal with both hands? Would you get shocked? What if you're touching the inside of the metal with both hands and then you also put your tongue on? Would you get shocked? Your common sense will say, wow, that's dangerous, right? Your common sense is going to tell you that, yeah, you will get shocked and possibly you're going to get yourself killed. In reality, nothing is going to happen to you. You can touch all the metal on the inside for as long as you want. As the airplane is getting struck by lightning, even if you're touching the metal on the inside, you're going to be perfectly fine. The insulating material on the inside is there because as you start to climb up to 30,000 feet up, it gets really cold outside. They're trying to protect you from the cold. So how is it that you're able to touch the inside of the metal while it's being struck by lightning and you're perfectly safe? How does that work out? I'm going to change the scenario just a little bit more. This time I'm going to place you outside of the metal of the airplane. Imagine that you're outside of the metal of the airplane. You're sitting right on top of the airplane. It's just getting struck by lightning. Would you get shot? So this time the airplane is the one which is getting struck by lightning. And so the question is, would you get shot? Yes or no? Your common sense will once again say, hey, it's dangerous. Of course you're going to get shot and possibly get killed. I got news for you, guys. You're still going to be fine. As long as you're not the one who's taking a direct hit, as long as it's the airplane which is taking a direct hit, you're still going to be 100% fine while sitting on the skin of the airplane. So the question is, why? All right. Let's do it. I'm going to give you guys a little bit of a break. Right after the break, we're going to go over the sort of mathematics that we will need to survive this course. So we will do some really basic math at some point, but this week only, maybe about half of next week, because numbers will play an important role in our understanding of motion. Once we're done with basic motion, we're going to stop using math. So I'm just going to go over some of the basics. So go take a break for 10, be back within 10, and then we'll take a break.